32-bit versus 64-bit systems. What are the differences between 32-bit and 64-bit systems? If you have used both of them, what kind of sharp differences have you experienced? Would it be a problem to use 32-bit programs on 64-bit systems in some cases?
Note, these answers apply to standard x86-based PCs, Intel and AMD, and Windows, as typically configured for end users. Other 32-bit or 64-bit chips, other OCs, and other OS configurations can have different trade-offs. From a technical perspective, a 64-bit OS gives you allows individual processes to address more than 4 GB of RAM each. In practice, most but not all 32-bit OCs also limit the total usable system RAM to less than 4 GB, not just the per application maximum. All pointers take 8 bytes instead of 4 bytes. The effect on RAM usage is minimal, because you're not likely to have an application filled with gigabytes of pointers, but in the worst theoretical case, this can make the CPU cache be able to hold half as many pointers, making it be effectively half the size. For most applications, this is not a huge deal. There are many more general-purpose CPU registers in 64-bit mode. Registers are the fastest memory in your entire system. There are only 8 in 32-bit mode and 16 general-purpose registers in 64-bit mode. In scientific computing applications I've written, I've seen up to a 30% performance boost by recompiling in 64-bit mode. My application could really use the extra registers. Most 32-bit OCs really only let individual applications use 2 GB of RAM, even if you have 4 GB installed. This is because the other 2 GB of address space is reserved for sharing data between applications, with the OS, and for communicating with drivers. Windows and Linux will let you adjust this trade-off to be 3 GB for applications and 1 GB shared, but this can cause problems for some applications that don't expect the change. I'm also guessing it might cripple a graphics card that has 1 GB of RAM, but I'm not sure. A 64-bit OS can give individual 32-bit applications closer to the full 4 GB to play with. From a user's perspective, application speed is usually faster for a 64-bit application in a 64-bit OS compared to the 32-bit version of the application on a 32-bit OS, but most users won't see this speed up. Most applications for normal users don't really take advantage of the extra registers, or the benefits are balanced out by bigger pointers filling up the cache. If you have any memory hog applications, like photo editors, video processing, scientific computing, etc., if you have, or can buy, more than 3 GB of RAM, and you can get a 64-bit version of the application, the choice is easy: use the 64-bit OS. Some hardware doesn't have 64-bit drivers. Check your motherboard, all plug-in cards, and all USB devices before making the switch. Note that in the early days of Windows Vista, there were lots of problems with drivers. These days things are generally better. If you run so many applications at a time that you're running out of RAM, usually you can tell this because your computer starts getting really slow and you hear the hard disk drive crunching, then you'll want a 64-bit OS, and sufficient RAM. You can run 32-bit applications, but not drivers, in 64-bit Windows with no problems. The worst slowdown I've measured for a 32-bit application in 64-bit Windows is about 5%, meaning that if it took 60 seconds to do something in 32-bit Windows, it took at most 60 times 1.05 equals 65 seconds with the same 32-bit application in 64-bit Windows. What 32-bit versus 64-bit does not imply? On x86 systems, 32-bit versus 64-bit directly refers to the size of pointers. That's all. It does not refer to the size of the cint type. That's decided by the particular compiler implementation, and most of the popular compilers choose 32-bit int on 64-bit systems. It does not directly refer to the size of normal non-pointer registers. However, usage of 64-bit arithmetic registers happens to require that the application and OS be running in 64-bit pointer mode too. It does not directly refer to the size of the physical address bus. For example, a system with 64-bit wide cache lines and a maximum of 512 GB of memory only needs 33 bits in its address bus, i.e. log2 512 times 1024 3, log2 64 equals 33. It does not refer to the size of the physical data bus, that's more related to manufacturing costs, number of pins in the CPU socket, and cache line sizes.
Basically, you can do everything to a bigger scale. RAM per OS. RAM limit of 4 GB on x86 for the OS, most of the time. RAM per process. RAM limit of 4 GB on x86 for processes, always. If you think this is not important, try running a huge MS SQL database intensive application. It will use in GT, 4 GB itself if you have it available and run much better. Addresses are 64 bits instead of 32 bits, allowing you to have bigger programs that use more memory. Handles available to programs. You can create more file handles. Processes. Example, on Windows x64 you can create in GT 2000 threads per process, but on x86 closer to a few hundred. Wider programs available. From an x64 you can run both x86 and x64 programs. Example, Windows, WoW 64, Windows 32 on Windows 64 emulation. Emulation options. From an x64 you can run both x86 and x64 VMS, faster. Some calculations are faster on a 64-bit CPU, dividing multiple system resources. A lot of RAM memory is very important when you want to run at least one VM which divides up your system resources. Exclusive programs available. Several new programs only support x64. Example, Exchange 2007. Future obsolete x86. Over time more and more 64-bit will be used and more x86 will not be used. So vendors will support only 64-bit more and more. The two big types of 64-bit architectures are x64 and YAR64 architectures. But x64 is the most popular by far. x64 can run x86 commands as well as x64 commands. YAR64 runs x86 commands as well, but it doesn't use extensions. There is hardware dedicated on Itanium for running x86 instructions. It's an emulator, but in hardware. As Phil mentioned, you can get a deeper look of how it works here.
The biggest impact that people will notice at the moment is that a 32-bit PC can only address a maximum of 4 GB of memory. When you take off memory allocated for other uses by the operating system, your PC will probably only show around 3.25 GB of usable memory. Move over to 64-bit and this limit disappears. If you're doing serious development, then this could be very important. Try running several virtual machines and you soon run out of memory. Servers are more likely to need the extra memory, and so you will find that 64-bit usage is far greater on servers than desktops. Moore's law ensures that we will have ever more memory on machines, and so at some point desktops will also switch over to 64-bit as the standard. For a much more detailed description of the processor differences, check out this excellent article from Ars Technica.
Nothing is free. Although 64-bit applications can access more memory than 32-bit applications, the downside is that they need more memory. All those pointers that used to need 4 bytes, now they need 8. For example, the default requirement in Emacs is 60% more memory when it's built for a 64-bit architecture. This extra footprint hurts performance at every level of the memory hierarchy. Bigger executables take longer to load from disk, bigger working sets cause more paging, and bigger objects mean fewer fit in the processor caches. If you think about a CPU with a 16K L1 cache, a 32-bit application can work with 4096 pointers before it misses and goes to the L2 cache, but a 64-bit application has to reach for the L2 cache after just 2048 pointers. On x64 this is mitigated by the other architectural improvements like more registers, but on PowerPC if your application can't use 4 grams it's likely to run faster on PPC than PPC64. Even on Intel there are workloads that run faster on x86, and few run more than a 5% faster on x64 than x86.
If you want to support the channel, please consider subscribing.